Hi everyone. In this presentation, I'm going to be talking about active noise control. More specifically, the physics behind it, its design, the different types, its applications, and its advantages and disadvantages. So what is active noise control? It is one of the two noise control methods, the other being passive noise control, which we will touch on later. In this mode of noise control, however, noise is controlled using wave interference. So what is the physics behind the system? More specifically, how does it use wave interference to control noise? Well, active sound control devices produce a sound that has the same frequency and amplitude as the surrounding noise, albeit this sound has a phase difference of pi compared to the surrounding noise. And from what we've learned in physics, a sound combined with another sound with similar amplitude and frequency, but a phase difference of pi, will result in destructive interference, which we also know from physics result in the elimination of noise. With all that said, what are the different components used in constructing an active noise controller? The first component is the plant, which is just a physical system to be controlled. For example, your headphones. The next and probably one of the more important components is the sensor. This is usually not a standalone device, but it's usually a combination of many small devices, such as vibration sensors and microphones that are used to detect the noise, whilst also monitoring the control system by measuring any remaining errors. The next device is the actuator. The actuator is usually a secondary speaker or vibration generator, and its primary job is to provide the anti-noise, per se, to counteract the surrounding noise. The last but certainly not the least important component is the controller. This is pretty much the brain of the system, and its job is to control the actuators based on the signals picked up by the sensors, as well as how the plant responds to the actuators. Next, I'm going to briefly touch on different types of active noise control filters. The first one is the finite impulse response filter. This filter, however, requires high amounts of computational power because it uses many filter weights. So an improved filter with fewer filter weights was used. This is the infinite impulse response filter. This solution, however, brought up other problems, such as instability and nonlinearity. Therefore, the most popular option, the adaptive linear neuron filter, was used because of its ability to act as an adaptive filter, its high processing speed, and its simple network architecture that had minimum elements. Where are active noise control devices used then? This may come as a surprise to you, but it is in fact gaining popularity in the aircraft industry, particularly for noisy propeller aircraft, such as the Saab 340B, which results in a reduction of noise of about 6 decibels. It is also gaining popularity in the automotive industry, which uses mics and speakers below the seats to suppress any road or engine noise. Lastly, the most popular option is noise-canceling headphones. These headphones are equipped with mics outside the ear cups to measure the surrounding noise and then play the anti-noise through the headphone speakers. Moving over to its advantages and disadvantages over passive noise control. Its main advantage is that it can achieve better noise canceling, especially if combined with passive noise control. It is also more cost-effective to use in large-scale applications where the amount of passive noise control installation needed would be too expensive or too heavy, such as an aircraft cabin. Lastly, it also has the added benefit of being able to reduce vibrations and mechanical structures. Its disadvantage, however, is that the devices that use active noise control consume more power, are more complex, and for smaller devices, are more expensive. Lastly, active noise control has its fair share of limitations. The anti-noise can be picked up by the reference mic. It is unknown what the effect of frequency shifts due to Doppler effect has on the active noise control, And lastly, it is currently unable to deal with higher frequencies. Here are the references used. Thank you.